starting with the graph of y equals ex. So y equals ex graph, that is here. By the way, let me graph over here. So the exponential function, okay, this is y-axis, x-axis, origin, this is 1, and x-axis becomes horizontal asymptote. So this is the graph of y equals ex. Use transformations to sketch the graph of each of the following functions and state its horizontal asymptote. Look, for this graph y equals ex, this x-axis which is same as y equals 0, y equals 0 is the horizontal asymptote. Now in part A, y equals fx equals e raised to x minus 5. This minus 5 suggests, this minus 5 means shift this graph 5 units to the right. So we need to shift 5 units to the right, and plus 1 means then shift 1 units up. Okay, so this minus 5 suggests shift the graph of ex 5 units to the right, this minus 5, and plus 1 suggests go up, and 1 unit up. Okay, now we can graph that. Okay, it's not nice. Let me try one more time. So we shift 5 to the right and go up. Let's track this point 1 0. So when we go 5 to the right, 1 2 3 4 5, so this will be over here, and 1 up, so 1 2, so this will be 1 over here. Okay, this point, when we move to the 5 to the right and up, 1 up means it will be there. So 1 2 3 4 5, and this will go 1 2. So this point will be 5 right, 1 up, so this will be here. Okay, so then the graph will be like this. Okay, this should have the same shape, just shifted 5 to the right and 1 up. Okay, now this is the graph of fx equals e raised to x minus 5 and plus 1 down here. Okay, now we need to find the horizontal asymptote. This is 0, this is 1 2, this is the x-axis, which is y equals 0, and horizontal asymptote will be then y equals, look, for this one the horizontal asymptote is y equals 0. It's shifted 1 up. 1 up means the graph is going 1 up, so y equals 1. So this will come to here now. Okay, let's try part B. Same idea. For part B, negative means reflect this graph about the x-axis. To get this negative, so reflect the graph of, okay, to get this graph, what we have to do, reflect this original graph y equals ex about the y-axis, this negative. Then we have e raised to x plus 2. This plus 2 means shift this, then shift 2 units left, then shift 2 units left, and minus 3 means eventually shift the whole graph 3 units down, and shift the graph 3 units downward. Okay, now we'll take a reference point, this 0 1, and do this work and find the graph. A couple of things happening here, so let's solve this problem in a couple of steps. So this graph, first we need to reflect about the y-axis. So reflect. So the first thing, this is not the final answer, but when we reflect about the y-axis, gonna get like this. So this is 1 0, now this is negative 1 0, this is negative 1. Then shift 2 units left. Now we need to shift this 2 units left, so negative 1 negative 2. So this negative 1 goes here now. Then next graph will be this original point. Now this is negative 1 and shift 2 units left, 1 2, negative 1 negative 2. Okay, and we'll have graph like this. It passes through here. Okay, this is negative 2. Then shift 3 units down. Then we have to shift everything 3 units down. This is 1 2, from here 1 2 3. It's already negative 1, now it goes to negative 4. So this point will be here. So the final answer is, so it will be negative 1 negative 2, and this will be now negative 1 goes 3 down, so negative 4, negative 1 negative 2 negative 3 negative 4. Here is the point. Okay, it was initially here the horizontal asymptote is x-axis, y equals 0. Same thing, y equals 0. Now it's shifted 3 down, so y equals negative 3. But here goes, and this will be the horizontal asymptote. This graph will be then, okay, because it's already shifted 2 units down, so something like this. So this is the graph of fx equals e raised to minus e raised to, anyway, it's just for part B. Okay, this is the graph of fx, or y doesn't matter, or g doesn't matter, negative e raised to x plus 2 minus 3, and this is y equals negative 3 is the horizontal asymptote. So HA y equals negative 3. Okay, final.